The Replication Lag Monitor provides real-time measurement and tracking of data synchronization delays across distributed database replicas. The system maintains a continuous stream of metrics collected at configurable intervals. Default interval is 5 seconds. Lag is expressed in milliseconds and represents the time elapsed since a transaction committed on the primary node until its application completed on the specified replica. The measurement process operates independently for each replica instance and does not require clock synchronization between nodes. Configuration of the Replication Lag Monitor is performed through a YAML manifest file loaded at system initialization. The manifest specifies target replica nodes by host name or IP address, measurement intervals in milliseconds, and historical retention duration. Each replica configuration includes a timeout threshold in seconds. Default value is 30 seconds. If a replica fails to respond within the timeout window, the monitor records a connectivity error and continues polling subsequent replicas without interruption. The measurement methodology uses transaction sequence numbers recorded on both primary and replica nodes. When the primary executes a transaction, it records the sequence number and commit timestamp in an internal registry. The monitor queries the replica to determine the highest sequence number that replica has applied, then calculates elapsed time as the difference between current time and the original commit timestamp associated with that sequence number. Historical lag data is stored in a circular buffer maintained in memory. The buffer capacity defaults to 10,000 entries per replica instance. As new measurements arrive, they append to the buffer in chronological order. When the buffer reaches capacity, the oldest measurement is discarded, making room for the new entry. The buffer supports iterative traversal in both forward and reverse chronological order without locking. Query operations against the lag monitor return statistical summaries over specified time windows. Available statistics include minimum lag, maximum lag, mean lag, median lag, and 95th percentile lag. Time window parameters specify start and end timestamps in Unix epoch milliseconds. If a window contains fewer than 2 data points, the query returns a null value for percentile calculations and reports the available measurements for min and max operations. The monitor implements automatic alert generation when lag exceeds configurable thresholds. Alert thresholds are specified in milliseconds and operate independently per replica. When a measured lag value exceeds its threshold, the system generates a single alert event and does not generate additional alerts until lag drops below the threshold for at least one full measurement interval. This prevents alert flooding during sustained replication delays. Network communication between the monitor process and replica nodes uses a simple text-based protocol. The monitor sends a query command specifying the highest applied transaction sequence number on each replica. Replicas respond with the sequence number, associated timestamp, and node status. The protocol includes fixed-length fields and line-delimited messages, simplifying parsing. All communication occurs over TCP connections with individually configurable idle timeouts. Error handling in the Replication Lag Monitor follows a non-blocking, degraded service model. If a single replica becomes unreachable, monitoring of other replicas continues unaffected. Connection errors are logged with timestamp and context information. The system maintains error counts per replica and resets these counts when connectivity is restored successfully. Replica errors do not prevent overall monitor operation and do not trigger process termination or restart. The monitor exposes its internal state through a read-only HTTP endpoint. The endpoint serves JSON-formatted responses containing current lag measurements, historical statistics, and system health status. The endpoint listens on a configurable TCP port, default is port 9000. Response payloads include timestamp metadata indicating when measurements were collected. Access control to the endpoint is enforced through network-level restrictions and optional API token validation. The internal threading model uses a single background thread dedicated to replica polling operations. This polling thread operates on the configured measurement interval, performing sequential queries to each configured replica. The polling thread maintains non-blocking S/O channels to all replica nodes and does not wait synchronously for responses. Data aggregation and historical storage operations execute on the same polling thread without additional synchronization primitives. Replica configurations support optional grouping into logical clusters. A cluster represents a set of replicas that service the same data set, but may reside in different geographic locations. Statistics queries accept a cluster identifier parameter to retrieve aggregated metrics across all replicas within the specified cluster. Cross-cluster queries are not supported and will return an error. Cluster membership is defined statically in the configuration manifest and does not change at runtime. The monitor maintains transaction log metadata to handle replica state transitions. When a replica transitions from disconnected to connected status, the monitor resynchronizes its transaction reference point. This synchronization step occurs automatically when connectivity is restored and does not require manual intervention. During synchronization, the monitor reads the full transaction history from the primary node for that replica only until synchronization completes successfully. Memory usage of the replication lag monitor scales linearly with the number of configured replicas and the historical buffer capacity. Each replica instance consumes approximately 200 bytes of fixed overhead plus 60 bytes per buffered measurement. A system with 10 replicas and 10,000 measurements per replica requires approximately 6 megabytes of memory. Memory consumption remains constant over time as the circular buffer maintains fixed capacity. The system supports optional export of historical lag data to external storage systems. Export operations run asynchronously on a configurable schedule and write data to a specified file path or remote endpoint. Export format options include comma-separated values and JSON. Failed export operations do not interrupt normal monitoring and do not prevent metric collection. The export process respects the historical buffer content and exports only data present in the buffer at export time. Starting the replication lag monitor requires specifying the configuration manifest path as a command line argument. The process performs initial validation of the manifest during startup and aborts if configuration is invalid. Upon successful initialization, the monitor prints a single line to standard output indicating successful startup, then enters background polling operation. The process catches all unhandled exceptions and logs them without terminating, allowing continuous operation in the presence of transient errors. Shutdown of the replication lag monitor is initiated by sending a SATERM signal to the process. Upon signal receipt, the monitor closes all active replica connections cleanly, flushes any pending data to the circular buffer, and terminates gracefully. The shutdown process completes within 10 seconds of signal receipt. Unsent export operations are abandoned. All subsequent monitoring requests will receive connection refused errors until the process restarts.